Okay, so this is a summary of what was in chapter 6. We learned everything about slopes. So I want to go through some of these as examples, and then I'll leave you guys some to practice on your own. So the first one right here, write the equation of a vertical line. Show me with your hands, which way is vertical? Right, this way. Okay, so a vertical line that goes through -2 and 5. So what I'm going to do is I'm just going to draw a quick little sketch. How quick is a little sketch? It's like 10-second sketch. -2 and 5. So like right here, -2, 5. Okay, that's the point. And as you guys said, I'm drawing a vertical line. I'm drawing a vertical line through it. So like this. So what is the equation of this vertical line that goes through -2? Yep. X equals -2, and that's it. Okay, so that's my answer. All right. The fact that you saw that you drew a line through -2, I know it wasn't going to be this. I knew it wasn't going to be this because it had nothing to do with the 5 right here. All right, so it was either X or Y. Since it's a vertical line going through when X is -2, it's X equal. Okay. So in that case, what is the equation of a horizontal line? Okay, so a horizontal line, 0, -1 is right here. Okay, horizontal line, meaning this way. So what that goes through -1. So what do you think the equation of that line would be? Sorry? Y equals -1. Right. Okay. And then this one, we mentioned it in class when we were talking about slope. There is a formula for slope when you're given the coordinates of 2 points. Which one of these is the correct formula for slope? Okay, Claire? B, this one. Remember, when you do rise over run, you're basically doing the difference between your two y values and the difference between your two x values. So that's why I know it's this one. Okay, you don't add, okay, and then it's not run over rise, so it's this one. Rise difference divided by the run difference. Later on, in about 10 minutes or so, we'll do a couple of examples with the formula. Okay, so this one right here, graph the set of equations on the same grid, compare the slope, y-intercept, and their effects on the graph. So this first line right here, what's my M, what's my B? For y equal x. This is actually the standard equation of a line. Jason.
Yeah.
Y equals x. What's my slope? What's my y-intercept?
Y equals x.
Yeah. So what's my slope here? Yep. Good. And 0. That's right. This is the same as saying y equals 1x plus 0. Okay. So if I were to graph this, y-intercept is 0. So it's right here. And my slope is 1, means my rise is 1 and my run is 1. Rise over run, rise over run. So up 1 over 1, up 1 over 1, up 1 over 1. All right, so there's my first line. Connect the dots. Remember with your slope, it's consistent throughout the line, so you can keep going forever if you want. Okay, there's my line, the first one. Okay, what about this one? What's my M? What's my B in this case? Y equals -x. Vincent? Right. Okay, so again, y equals mx plus b. What's the number in front of the x? -1. And the b is 0. So again, my y-intercept is right here. Since my slope is -1, or -1 over 1. Avian,
Yes.
with a slope of -1, what am I doing?
Uh,
Am I going up or down?
Down.
Down 1 and 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. Like that. Okay, and I can keep going on forever as well. Okay, and that's my second line. Okay, what about this third one right here? Let's say Justin. Third one. What do you think is my M? What do you think is my B?
Uh, -5/1,
Good.
and the B is 0.
Perfect. Excellent. So again, my y-intercept is 0, so I'm right here at 0, 0. But this time, since my slope is -5 or -5/1, okay, how much am I going up or down by? Shakai? So for my slope -5, should I go up or down? Down. So down 5. 1, 2, 3, 4, 5. And what am I going over? 1. That's right here. And then 1, 2, 3, 4, 5 again, and over another one. And there's my third line. Okay. So there's my 3 lines. Now remember on Tuesday when you guys compared the lines, what can you say about the red and the blue line? So how do you go from the blue line to the red line? What happened to it? Vincent? Not reflection. Well, actually, yeah, this one. Actually, yeah, you know what? No, is it? No, not quite reflection. Not quite. Rotated how much? 90 degrees. Okay. So if it's a reflection, you would have exactly the same points, but this one is actually it is. It is a reflection as well. Okay. Yeah. So if you can say that from the blue line to the red line, you rotate it 90 degrees. Alright? Or because notice the points, I didn't graph it properly, that's why it was off a little. That's why I didn't see it quite the same. If you put a mirror on the y-axis, you can see that this line is reflected on the y-axis. So this is also a reflection on the y-axis. Right? Since all the numbers are just 1, 1, 2, 2, 3, 3, 4, 4, like that, other than a reflection on the y-axis, it's actually also a reflection on the x-axis. Right? Because if you flip this over this way, you get this line too. Okay. Okay. Now, if you compare all 3 lines, which line is the steepest? Claire? Y equals -5x. That's right. The bigger the number, the steeper the line, no matter if it's positive or negative. So this line, this one is also the steepest. Okay, so it doesn't matter if it's positive or negative, but the bigger the number, the steeper your line. Okay. Let's try this one. Let's try to graph these 3 lines then. Okay. So same thing. What is my M? What is my B? Nick. Good. -1. And my B? 0. That's right. Okay. So I have y-intercept of 0, which is right here, right in the origin. And my slope of -1 means, should I be going up or going down? Suhan? Sorry?
What was the question?
Okay, so I have this point. My slope is -1. So what should I do from this point?
Go down.
And then? Which way do I go? Left or right?
Left.
Think again? Right. Okay. If I went left, my line would go this way, right? But I know it's a negative slope, so I know it goes this way. So down 1 over 1, down 1, 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. We always go right. Because when we take care of the up and down, and it already takes care of the negative. Okay, so there's my first line. Okay, second line. Okay, let's see. Cyan, what's my M and what's my B?
-1 and 5.
-1 is my M and 5 is my y-intercept. Good. So where's my first point? Let's see. Genevieve, where's my first point? 5 on the y-axis. That's right. So you always plot the B, your y-intercept first. Okay. And then from that point, Shakai, what should I do? If it's -1? My slope is -1, so should I go up or down? Down 1, and then it's 1 over 1. So -1 over 1. So down 1 to the left or right? Sorry? Right. Right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Okay. Keep going. And then there's my second line. Okay. And then the third line right here. Denny, what's my M? What's my B? Yep. Perfect. Okay, Capuchin. Where's my first point? Okay, so I need to plot my first point first. So given that my M is -1 and my B is -5, at -5. That's right. Okay, there's my first point. Okay. And then Ali, my slope is -1. So should I go up or down? Down 1 and right. Good job. Hey. Hey. Okay. And there's my third line. Okay, looking at these 3 lines right here, what can you say about all 3 lines? Yep.
They're the same thing. They're the same direction.
Same direction. Okay, I'm looking for the specific word that starts with a P. Vincent? Parallel. What tells me that, like, so even if I drew horribly, okay, my lines are all crooked and everything, but what part of this right here tells me that all 3 lines should be parallel? Claire? Same slope, right? So notice all 3 have the same slope, which means they are parallel. Same slope. Okay. So from the how do I go from the blue line to the red line? What did I do? Did I do a rotation? Did I do a reflection? What did I do to go from the blue to the red? Vincent? Translation, that's right. Okay, so to go from the blue to the red, I translated the whole line. Translate it up 5 units. And then to go from that blue to the black, I translated down 5 units. Okay. So on Tuesday, when you guys worked in your groups, this is what I wanted you guys to come up with. Okay. And then I know the supply teacher yesterday also took up those pages with you guys. So the 3, rotation, reflection, translation. Those were the 3 main things I wanted you guys to get out of that lesson. Okay. So far, so good? Okay, remember, this is nothing new. This is something that you guys worked on for the last 2 days. Okay. So, multiple choice. Okay. Given the slope of 3 lines, m is 1, and the first line has a slope of 2, the slope of the second line has 5, the slope of the third line is -4. Which line would you say is the steepest? Okay, so 2, 5, and -4. Which line is the steepest, meaning the most vertical? Uvin? 5. Yeah, this one right here. Because as I said, the bigger the number, the steeper the line. So which one is, did they say this one? The line with a slope of 5 is the steepest because the absolute value of 5 is larger than the absolute of 2 and -4. Absolute means disregarding the positive or negative sign. So basically what I was saying, doesn't matter positive, negative, just the biggest number. Okay. What is the relationship between the slope of 2 parallel lines? So we just talked about this. Let's see who was paying attention. Derek. Parallel lines. Sorry? Reciprocal of each other means they're perpendicular. C? Oh, C. Yes, they are equal. That's right. Okay. So 2 parallel lines, slopes are equal. That's what we were just saying, summarizing. Okay. And then this was from Monday's lesson. Determine the slope and y-intercept and then graph. Okay, so what's wrong with this equation? There.
The x is on the left side.
Right, so it's not in the proper format. We want the y equal mx plus b format where it's only y on the left side. Okay, so that means we have to rearrange it. So 3x minus 5y equals 20. Okay, what am I moving to the right? Capuchin, what am I moving to the right? 3x. Okay, when I move it, I'm left with this. What happens to it when I move it, Capuchin? Negative. Okay, let's put that phone away. I'm going to keep calling on you. Okay. And then what do I do with this -5? Vincent? Yeah, divide everything by -5. Okay, so let's clean this up. Now that I moved that -5 over, what's left on the left side? Just y equal. And then What's negative 3 divided by negative 5?
Positive 3 over 5.
Positive 3 over 5. Good. And then, whoops, yeah. And then 20 divided by negative 5. Avion, 20 divided by negative 5? Sorry? Positive 4? Negative 4, so minus 4. Okay, so what's my M and what's my B? Uvin? Good. Okay. So now to graph it. Nick. Okay, what do I graph? What's my first point? Negative 4. Right. So negative 4 on my y-axis. I always graph this point first. Okay. And then from that point, if my slope is 3 over 5, Shakai, what should I do? If my slope is 3 over 5? Go in the elevator and go up how many floors? Rise over run. Rise over run. So go up 3 floors. 1, 2, 3. When I get out of the elevator, 5 to the right. 1, 2, 3, 4, 5. Right there. Okay, and there's my line. Okay. For this one right here, do I need to rearrange? Do I need to rearrange this equation, like do all this right here? Nope. Why not? Claire? Right. Because y is already isolated. It's already in y equal mx plus b. Right? So this, I can easily just tell slope is negative 1 over 2, and b is negative 5. Okay. I'm gonna leave those ones for you guys to try. These ones, what about these ones? Do I have to rearrange it? Yeah, all of them you do. Okay. Let's do this one. Yeah. The numbers are all messed up because I was cutting and pasting and drawing and stuff. Okay, so number 17. This one. Okay, I want to find the slope of this line. Okay. I don't see any points on the line, so what should I do? We talked about this on the other day. Kavishan, if I don't see any points on this line, what can I do? I don't see any points, so I need 2 points. So what should I do? Yeah. Yes, just pick your own. Pick your own. Pick the best points. What do you think is the best point to choose? Vincent. The one on the line. Well, this one I don't think is really right on the number, but y-intercept, you always want to choose this one. Right? Because the y-intercept, it kind of kills 2 birds with 1 stone. Okay. This one, even though it's on the x-axis, I don't want to choose it because it's in the middle of 2 numbers. So if you look carefully, which point does it look like it's right on the dot? Yep. 3, 0. Okay. Or let's just make it more interesting. Yes. Okay. So I just chose this one for the sake of the lesson. Okay. So let's say I chose 6 and 1 right here. Okay. If I do my rise over run, remember going from the left point to the right point? Okay, what's my rise here? 2. What's my run here? 6. Rise over, so is it 2 over 6 or 6 over 2? 2 over 6, because rise over run. I don't see this answer here. Derek.
1 over 3.
Because you can reduce this to 1 over 3. The answer is A. Okay. Had I chosen, like let's say 9 and 2, like this point right here, would I get the same answer? If I chose this point, it would have been 3 over 9. And when I reduce it, what do I get? Say again?
1/3.
1/3. Right. So it doesn't matter which point you choose, it should be the same slope throughout. Okay. Let's see. Okay, let's go to here. Number 23. Number 23. Okay, so number 23 here. For your assignment on Tuesday, you won't need to know how to do this mathematically. Okay, but I don't think this is hard to go over, so I wanted to just do it now. So you're given 2 points. I can use that formula. M equals y2 minus y1 over x2 minus x1. Okay, remember we mentioned about this formula. So what are these y2, x1? Like what are these? This is my first point, so I'm gonna name this x1, y1. This is my second point, so I'm gonna call this x2, y2. Alright. Remember every point has an x and a y. And so since this is my first point, it's x1, y1. Right? I've seen a lot of people label it and write x1, x2 or x1, y2. Right? So you have to know how to write this. Even though I taught this course for a million times, I still write these subscripts on top because it does help. It does help when you substitute. Okay. So what is y2? So looking at these numbers, what's y2? Vincent, -2. Okay, what's y1? -5. And then Vincent, if you can finish off for us, x2? Right. Okay. So that's what I mean by it does help when you write that little subscript on top and then you substitute it in. It really helps. Okay. If you're good with mental math, go for it. If not, you have the calculator to help you with these negative numbers. So -2 minus -5, you get +3. -4 minus -3, because 2 negatives make a plus, you get -1. What is 3 divided by -1? Yep, -3. So there's my answer. Okay, so that's how you use this formula. As I said, I don't think it doesn't need a lesson on its own. That's why I'm just teaching you guys this now. We will get more into using this formula in chapter 7, okay, when we do a lot more mathematical work. Okay. Lastly, on the back with that blank page, I want to go over coefficient, correlation coefficient. One last thing. Yeah, correlation coefficient. Does it have anything to do with slope? Okay, it has nothing to do with slope. All right, you can, I guess, if only the positive, negative part. The value of correlation coefficient. What's the minimum? What is the minimum value? Can it be negative 100? No, what's the minimum value? Negative 1. Okay, all the way to, yep, 1, positive 1. Okay, so that's the minimum and maximum value of correlation coefficient. So what it measures is how tightly or how related two variables are. So let's say I have points like this. Okay, my graph looks something like this. Okay. Here, I'll add a few more dots. That's better. Okay, so how would you describe this? Do you think it's pretty, like, do you think there's a relation, basically? Yes. So that's why there's like correlation. So it's like saying, is there a relation? Yeah, I think so. I can draw a line of best fit through it. Is it perfect though? Is every single line in line? No. Okay, so I can't say it's perfect, but I can say it's strong. Okay, positive or negative? Positive. Yeah, so this is a strong positive. If I were to give an estimate, oh, by the way, coefficient correlation, we use the letter R. Okay, just to give an estimate. You guys won't need to actually measure exactly the correlation coefficient until grade 12. Okay, so if I were to just give an estimate of a strong positive correlation, it will be, give me a number close to 1. 0.9. Yeah, there you go. Something like that. Okay, now let's say I have this one that looks like this. Okay. Okay. Do you think how strong do you think is this correlation between the x and the y?
Weak.
Weak. Yeah, not strong at all. So what do we call not strong at all? We call it weak. All right. Do you think the direction is positive or negative? Negative. So it's a weak negative correlation. Okay. Give me a value that's close to negative 1. But actually not between 0 and negative 1 because it's so weak. Yeah.
Negative 0.25.
Yeah, negative 0.25. So that would be an example of a weak one. Okay. If I say negative 0.9, is that strong? Yeah, it's actually very strong. Okay. So if I have a graph that's like all over the place, like I have a, okay, like this, what would you call that? Yeah, no correlation. So, and what is the value of that? R equals 0. Excellent. Okay. So, for the rest of the class, finish up this package. It's a summary of chapter 6, basically everything that you need to know about slopes. Your assignment is Tuesday, so yeah, there you go.